Okay, so let's start with Pierre-Olivier Lagage, who will give us the status and science goals of JWST that we hope will be successfully launched soon. Pierre, Olivier.
Yes, thank you for the invitation. So let's talk about Webb, because now the James Webb Space Telescope is called Webb. So it's a very exciting time because now we have a launch date. So it will be launched on the 18th of December this year by an Ariane rocket and will be in operation during 5 to 10 years. So it is a 6.5 meter telescope. It is the largest telescope to be sent in space. You can see here compared to a person, how big it is. And it will be packed and will deployed once launched. One critical part of the deployment will be the deployment of the thermal shield, which prevent the light from the sun, Earth, or even moon to hit the infrared telescope, so it has to be cooled to temperature around 50 K. So James Webb is often considered as the successor of JWST, which on a way it's true, because one first use, or at least initial use of Webb will be to look far in the past, which means far away, and to have the first light after the dark age. But it is not what is the most important for PCMI. The most important thing is that it is also the successor of Spitzer. Here you have the wavelengths from 0.1 micron ultraviolet to far infrared. So you can see here the wavelengths covered by JWST, the covered by James Webb, so from 0.6 to 28 micron, and here the wavelengths covered by Spitzer, which were going up to the far infrared, but we have part of Spitzer wavelengths covered by Webb. And the difference in size is really huge, because Spitzer was a 85 centimeter telescope and Webb is a 6.5 meter. So in terms of collecting area, there is an increase by a factor of 50, so which is really huge. And you can get with James Webb a sensitivity at least 10, even 2 orders of magnitude, almost better than Spitzer in the range covered by both. And also, of course, in the near infrared, you have also a huge increase in terms of sensitivity. But it's not only an increase in terms of sensitivity, it is also a tremendous increase in terms of angular resolution. And for the studies of this, for example, it will be really a huge benefit to have such a large telescope. Here it is a simulation of a disk around at 24 microns. On the left, you have what has been observed by Spitzer, and on the right, it is a simulation of what could be seen. Of course, it depends how the disk is, but what could be seen by the mirroring instrument in the mid-infrared. So there are 4 instruments for Webb. So NIRISS, a near infrared imager and slitless spectrograph, NIRCam, a near infrared camera, NIRSPEC, a near infrared spectrometer, and only one instrument which cover the wavelength range from 5 to 28 microns. here you have the detail of the various modes of the various instruments. So here again, the wavelengths. So from 0.6 to 30. So here the various mode of the instrument. So you have imaging with NIRCam, MIRI to cover the full wavelength range. You have chronography possibilities with NIRCam and also with MIRI. And you have after possibility to do spectroscopy, again with NIRSpec, MIRI, NIRIS, NIRCam. So you can do multi-object observation with NIRSpec, SIG and slit spectroscopic observation with NIRSpec or MIRI, and integral field unit spectroscopy with NIRSpec and MIRI. A point I would like to stress here is that the instruments are complex, at least for space instruments. It is the first time that we will have a MOS in space. Same for chronograph for MIRI, which are phase mask chronograph from Observatoires de Paris, LESIA, which were quite new at the beginning of MIRI. And another crucial point for the observation, there is only one phase to propose an observation. It's different from HS2, where we had two phases, one phase for science, one phase to implement the observation. There you have to do both things within the proposal. In terms of science, it's four teams are put forward. First light and organization, assembly of galaxies, birth of star and protoplanetary system, planetary system, and the origin of life. So it is really the flagship mission from NASA. But it's a participation of Europe, so ESA, and of Canada. So what is the participation of Europe? So it's in terms of the launcher, Ariane. It is in terms of instrumentation. NIRSpec is fully European. It has been provided by ESA and built by within industry, and MIRI is 50 Europe and US. And also Europe ESA is provided 15 ESA staff members at the Science Operations Center, which is at the STSCI in Baltimore. And in exchange of this contribution, Europe have at least 15% of the time. So I don't want to hear that we don't have time it's difficult to have time for web. Indeed, we have at least 15%. And we will see that, in fact, for the first call, we had 30%, is great. So we will have some difficult nights during the deployment, which will last 14 days. And then to go to the L2 point, it will take 1 month. And from that, there will be 5 months of checkout of the various instruments, phasing of the mirrors. And in June, we will be ready for scientific observations. So there are 3 types of observation. There is a guaranteed time observation. So about 4,000 hours have been allocated for those who have built instrumentation or which have followed the of James Webb. In fact, we have this time during the first 3 cycles. One cycle is 1 year, but most of the time, 80% will be used during the first year. Then there is a director's discretionary time, which is up to about 900 hours. And the particularity for this first cycle is that the director has decided to spend this time as early release science. I will go back to that in a minute. And then you have the normal guest observer programs open to the community. And it is a large amount of the time, 80% is for observer. So you can find all the approved GTE program at this address. And as you can see, James Webb will cover almost all the subjects in astrophysics, from solar system to deep fields. So about early release science. So the data, we have to know that the data are immediately public. Those who are PI have to deliver some data reduction package. And the rationale being this early release science was to provide to the astrophysicists interested in James Webb data very early after when science observation have started, so that they can have data before applying for the cycle 2 proposal. So that was the rationale behind that. And in France, we have Olivier Bernet, who is PI, and Emily, who is co-I of one of these ERS program about radiative feedback from massive star as stress by multi-band imaging and spectroscopic mosaic. So it's really great that we have a PI of such a program, but we are also PI of many programs. So I really encourage you to contact the PI if you are interested in those data. It's something which is really open. Here are the various programs. In terms of geo observations, so there are various kinds of observations: small, less than 25 hours, medium, between 25 and 75 hours, and large, greater than 75 hours. So the guarantee times they observe are proprietary during 1 year, except for the large program. Here again, it's immediately open. So in terms of number of proposals, there have been about 1,200 proposals. The pressure is not so high. It is between 4 and 5. So in the various, you can see the various panels to discuss the proposals. Again, various, all the field in astrophysics are concerned. And what is interesting, at least for those who have built instruments, is to see how often they are used, they will be used. For example, for MIRI, it's about 30% of the time will be used for MIRI. For NIRCam, it will be 21%, NIRIS about 5%, and for NIRSPEC is 4%. So those who have built MIRI were really with this result, because maybe you know or not, but at the beginning, MIRI was not an instrument for the Webb. Only 3 instruments in the mid-infrared, because MIRI require active cooling, for example, so it was a bit more challenging in terms of techniques. But at the end, we are pleased that this instrument is really an instrument which will be used. And also you can see that Europe with NIRSPEC and half of MIRI is really well in the instrumentation, the instrument which will be used. So in terms of the various countries, so here you have France. This is a proposal with PI, GU proposal. you can see that we had 45. We can compare with Germany, 53, and UK, 100. So in terms of approval, we had only 6, which is not the best. For example, Germany had 14. Generally speaking, I think we can do better in terms of approve PI or co-PI proposal. And there is a questionnaire which has been sent to through various national programs to have feedback from the community about the web proposal. Martin Giard is leading the group in charge of discussing the various proposals. But in terms of COI, here is the various COI in the proposal. And in terms of approval, we have 144 COIs. In fact, some are on 2 proposals. And if we just take the number of COI, we arrive at about 100. So 100 people in French lab are associated one way or another to James Webb proposals. Okay, so we have to be ready for the next call. So when will be the next GEO call, guest observer call? In fact, so the launch, this is not the right time, it was a very, so the launch is December. So 6 months later, after the commissioning, we will have the start of science observation. So the call for cycle 2 proposal will be so in November 2022, with a deadline to answer in February 2023. So it takes time to have a good proposal. So the advice we can give is do not wait for the last minute to have James Webb proposals. Given the expertise we got with the building merely developing with CNES, we have developed a French Center of Expertise for MIRI. And if you need help, you can contact us. So we are more expert in terms of imaging, coronagraphy, and low resolution spectroscopy, but we are getting more and more, thanks to IAS and an INR project, more expertise also for the MRS, medium resolution spectrometer. So don't hesitate to contact us. And there is a website where you can find the information and the way to contact us if we can help for have better success in web proposal. So thank you for your attention. Yeah, I am ready for to answer questions. Can you hear me?
Yes, we hear you. So are there questions in the room? No?
This is Ludovic, so maybe just a very basic question. How do you explain the success rate for the proposal applications compared to the other European countries?
So we have set up a committee led by Martin Giard, and we are trying to understand this. So we have not yet the final answer to this question. So we have remarked, we have received yesterday the total remarks from the questionnaire we sent, and we have not yet had time to digest it, but we are looking for that.
When will it be the next call for proposal?
So the next call will be so in November 2022. So it seems that it is far away in 1 year or more, but I encourage you to think to it in advance and to look at data which will be ready for everybody during the first months of web observation, science observation.
So when the launch will be done, how long before the first observation comes?
So you have the launch in December. Then you have a phase which is called commissioning, because you have to the phasing of the telescope. It is 18 hexagons with actuator behind each hexagon, and you have to phase all that. Then you have to have the commissioning of the instruments, and MIRI will be the latest instrument to be commissioning because it has to be passively cooled, and to say that we are ready for scientific observation. So the scientific observation will start end of June, beginning of July. For the early release science observation, they will be done within the first 6 months after. So it will be done between July and the end of December.
And so when the observations are done, they are released directly, or what?
Yeah, exactly. Yeah, they are public for this ERS observation. They are public immediately.
I mean the reduced data or the raw data?
Oh, there will be some data reduction done at STCI automatically. So you will have access to this reduced data, but that ERS PI will improve the data reduction. So that will be within the ERS team that there will be some enhanced data reduction possibility. And this will only available, I don't know exactly when they have to deliver it, but within the few months after the observations. But you have a pipeline, you have an automatic pipeline, and the delay of the James Webb made it more robust.
Okay. Quentin? Quentin asked first, so you will come after. Quentin, are you on?
Yes.
Can you ask your question?
Yeah, I was wondering about the time allocation. Was the priority given to the US and Europe? And what about other countries, in particular, like in development countries like Mexico, South Africa, Brazil, or other, let's say, small country in terms of astronomy community?
Oh, first, the call is open to any country. And second, the review are double blind. So you don't know, the referee don't know who has made the proposal. So you can see that there have been, I have not it here. But you have many countries with small contribution, small program, but not only in Europe or US or Canada.
And are there some available statistics about this?
Yes. I can. Yes, there is statistic. I can I will put in the chat the slide where you can find all the statistics.
Okay.
It would be better
if
you would put it on the, not on the chat, but on the document, on the Google Docs for the questions.
Okay.
It's because the chat does not last. Cécile.
Okay, thanks.
Je parle dans le micro, c'est ça? Just I was surprised by the pressure that you mentioned, factor 4 to 5, which is pretty low, as you said, and it's very it's a factor of 2 less than HST. Old HST is between 8 and 10, I think. So, do you have an explanation for that? Was the institute very disappointed by this number, or what are there? Do you have something to say about it?
Difficult question in the sense. Yeah, I think the institute was a disappointment because we were more, in fact, in the spirit of having a factor, a pressure of 10. That was also the case for ALMA. No, I don't know exactly the reason. You know, there are still a lot of proposals, more than for HST in a sense. And there is also more, even with the GTO, there are more times than HST, because HST has a low orbit and there are some lost time. So the fact that we have more time, that HST can also reduce the pressure. It's not a dominant factor, I think. So no, I have not a good explanation. But there are new, the statistics, there are newcomers compared to HST. So there are more in terms of number of astrophysicists as COI, or there are more than for HST, which is something interesting. So in any case, it's a good news to people who want to propose. So the pressure is not so terribly high at the moment.
There is another question by Michel. Michel Guéna, are you on? So I will.
Yes.
Okay,
I am here. Yes, I would be interested to see a kind of comparison between what happened with Herschel, the Herschel satellite, and what is in this first program committee for the GEO programs. I noticed that I was in this committee for Herschel and noticed that there was a very strong bias to, I would say, simple proposals, obvious and simple proposals, and in particular imaging. And most of them were a continuation of a science which was done before on a much, much smaller scale. And I would be interested to know if we already see this bias between the instruments and the observing modes.
In fact, it's the reverse. You can see that imaging is only 30% of the time, and 70% of the time is spectroscopy. And it's not a surprise because James Webb would be more an instrument to characterize things, for example, atmosphere of exoplanet, rather than discovering, looking for new objects. It will be done for deep survey, of course, dark age and so on. But otherwise, for the other subject, it will really be looking at deeper, more physics on the non-objects. That's how I explain that spectroscopy is 70% of the time and imaging only 30%.
Okay, thank you, Pierre-Olivier.